Welcome to the walkthrough for Assignment 2C. The purpose of the third part of this assignment is to deepen your understanding of how to develop asynchronous microservices with Spring WebFlux, the Eureka Discovery Service, the Spring Cloud Gateway, the HTTP Interface Declarative Client API, and the Reactive Relational Database Connectivity, or R2DBC framework. In this assignment, you'll apply R2DBC to create a database that stores information about movies and supports various asynchronous SQL queries, including a custom SQL query, as well as apply HTTP interface mechanisms to create several declarative client APIs that access database and timer microservices asynchronously via an API gateway. The code you write for this assignment does not have a GUI and runs as a Spring application with an integration main program and unit tests. Please feel free to use this main program and the unit tests to help debug your solution. The following resources may be helpful in completing this assignment. Videos and tutorials on R2DBC appear here, and a tutorial on the HTTP interface appears here. Naturally, we'll cover this material in class, which will be available in my YouTube playlist. The Database EX microservice is packaged as a project using IntelliJ. This app is written in Java and demonstrates various Spring WebFlux, Project Reactor, and R2DBC Persistence features. For the purposes of Assignment 2C, however, just focus on the following directories. Client, which contains a client main driver program containing proxy skeletons you need to fill in, as described below, and Database EX, which contains the R2DBC-based database microservice server skeletons you need to fill in, also as described below. In addition, you need to copy your Movies EX and database microservice implementations from Assignment 2B, which is found in these folders. Movies EX, which contains the skeletons you need to fill in from Assignment 2B, the various client portions of Movies EX in the tests folders, which contains the proxy-related skeletons you need to fill in from Assignment 2B, and database, which contains the skeletons you need to fill in from Assignment 2B from the database microservice. And finally, client, which contains the skeletons you need to fill in from Assignment 2B. You'll also need to update the skeletons there to add the Assignment 2B portions of client. Please be careful not to overwrite the test provided with these microservice implementations, since they've been updated for Assignment 2C. You need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Do not change the overall structure of the skeleton. Just fill in the to-do tasks and do not delete the to-do markers, or your submission will not be reviewed. In particular, you need to finish implementing the to-do tasks for this assignment in the following files and folders. Client, where you need to complete the to-do tasks in various fields and methods to implement a declarative client proxy using HTTP interface. Database EX, where you need to complete the to-do tasks in various fields and methods of the database service.java file, multi-query repository impl file, and the database service.java files that use declarative and programmatic features of R2DBC in conjunction with Project Reactor streams to return Flux objects containing informations about movies that can be processed asynchronously on the client and the server. You also need to complete the to-do tasks and factor methods in the client.beans.java file that can be injected into Java classes using the Spring auto-wired annotation. Finally, you need to implement the to-do tasks in the movie.java file. As usual, your solution should strive to use few, if any, loops or if-else statements in this assignment, and instead use Java functional programming features, including Lambda expressions, method references, and Java stream aggregate operations, as well as Project Reactor reactive programming operators. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Solutions that are not commented thoroughly will not be reviewed. Skeleton code for this assignment is available here in my GitHub repository. Please pull this skeleton code into your GitLab repository, review it carefully, and complete the to-do markers. There are unit tests that exercise all the to-do tasks you must complete. To compile and run these tests, you need to use the provided IntelliJ project. You can run all the unit tests by opening the Gradle tab, followed by navigating down to the Tasks Verification Check submenu. All you need to do is double-click on the Check submenu, and all the tests will build and run automatically. These tests increase our collective confidence that your solution is working as expected. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the test to detect problems in your code. In particular, I'll also provide videos that walk through frequently made mistakes that you should address. Please address these issues prior to your submissions to streamline our programming assignment review and assessment process. Assignment 2C is designed to further deepen your understanding of developing asynchronous microservices using Spring WebFlux, the Eureka Discovery Service, the Spring Cloud Gateway, the HTTP Interface Declarative Client API, and R2DBC. The skeletons and tests are extensive, though you don't need to understand them all to complete your solution. This assignment is a bit more complicated than assignment 2B, so please start early and ask questions in class, office hours, and on discussion forums to ensure you complete this assignment successfully. So now that we've walked through the specifications for assignment 2C, let's go ahead and take a look at the skeletons. First of all, a lot of the code is really very similar to what you had before. You have to go and modify the model that's here over in the common portion of the project and the common module. You'll have to go and put the solution that you added for assignment 2B here for the database portions. You have to put those in there. You'll notice I refactored the code just a tad to split things off more sensibly, but you'll be able to find it. There's a repository and a server folder. So go ahead and watch the video we did for assignment 2B for more about that. You'll likewise have to go ahead and add the part that you did for Movies EX, both in the source main portion and the very specific part here that's over in the client beans and movie sync proxy for Movies EX. So that's all stuff that we covered before. So I'm not going to spend any time on that here. You can go back and watch the other video. Just be careful when you add in your code that you don't overwrite existing tests, because we've improved the tests for assignment 2C. So please be careful not to copy the tests over from your solution to assignment 2B. What I am going to talk about, though, are the parts of the software that you have to actually add that's new. So one of the key parts is database-ex. And over here, you're going to have to implement a couple of things. You're going to have to implement the database EX service, which, as you can imagine, based on what you did for assignment 2B, is largely making the appropriate calls to the corresponding methods that are from the database repository and also the multi-query repository impl, which we'll talk about. So these are all just basically adding in method calls that call through the M repository field here in database EX service. So let's go take a look at database repository. You'll see again, I moved it into a new package just to make it a little cleaner. So database repository extends the CRUD repository, the reactive CRUD repository, and it also extends the multi-query repository interface, much like you did in assignment 2B. Now you have to provide a couple of methods here that are going to use the Spring Data API, but be aware that this time we're going to be using Fluxes as the return type as opposed to using lists. So that's going to be the major difference. Other than that, the method names are pretty much the same as what you did for assignment 2B, just returning a different type. Let's go take a look at multi-query repository. This is, of course, quite a bit different because we're using a totally different technology this time. In this part of the assignment, for assignment 2C, we're actually using the R2DBC reactive database as opposed to the JPA synchronous database. So if you watch the other videos we'll go over in class that talk about how to program for R2DBC, this is a variation of those solutions. And you have to implement a couple of methods, one called find all by ID, containing any in order by ACE, or S, which stands for ascending. And then you'll also have to implement find all by ID containing all in order by ACE. And so this is going to contain all the queries have to match in order for a match for the movie. And up here, you just have any of the queries match in order to get a match for the movie. And you'll have to write the code in here that does this. And if you take a look down here, you'll see we have a couple of helper methods. We have one called build query string, which you'll have to implement to basically return a string that replaces the params placeholder in the SQL string param, which you're going to pass up here in these methods, with a string that's got a concatenated set of wildcard values based on this list of queries, and then also adds the order by clause to make sure that the result set is sorting in ascending order by the ID column. And this will all be done in a case-insensitive manner. So again, you need to watch the videos that we'll go over in class for the quote services case study to see kind of how to write this method. It's very similar to what we go over in class. And then down here, we have a method called getMovieFlux. And this is going to execute an R2DBC SQL query against the database. And this is similar again to what we're going to go over in class. The main difference being that you're going to have to use a couple of helper methods. This one's called arrayUtils obj2list. And this is a helper method that is used to extract the vector as a list of doubles. And that's going to take a little bit of thought. It's actually not too hard, but you just have to look carefully at the API that comes with ArrayUtils obj2list. And we'll go over that in just a moment. But this, again, is very similar to the example that we are going to cover in class as part of the quote services case study, the new revised version of this that uses the R2DBC variant, I believe, for the handy microservice. So those are the things you're going to have to implement here. Pretty cool, actually very cool. I think arguably easier to understand than the JPA example that we did for assignment 2B, but I'll let you be the judge of what you think makes the most sense. So now let's go over and take a look at a couple of other things that you'll have to do. I already talked about how you're going to have to do the common movie portion. That's the part that is based on what you did before. So please make sure you use the same mechanisms. You'll notice I added a warning that suppresses that annoying thing about JPA attribute type inspection, so that won't plague you anymore. Over here is the ArrayUtils file. This is the one that you're going to have to use to do the multi-query repository implementation. And you'll see it's got a couple of helper methods in here. And the one you're going to want to focus on is object or obj2list. That's the one you're going to have to figure out how to use. This is actually very, very cool and works around some interesting quirks with the R2DBC mechanism. Okay, the other thing you're going to have to do is come over to client. This is the part that's new again. And we kind of click down here and you see that we've got a couple of things here. This is the client beans portion. And you've got some stuff you got to fill in here. You have to fill in the factor method that's a bean that makes the database EX API. We'll look at that in a second. You have to make the database API. We'll look at that in a second. And you have to make the timer API. And you'll see here that these two methods, get timer API and get database API, are pretty much the same thing that you did in assignment 2B using retrofit. Up here, in contrast, this implementation uses the new HTTP interface mechanisms that we've talked about. And so it'll make the appropriate HTTP interface. So make sure you take a look at that and get a feeling for how that works. And down here, I should probably put return null so it won't yell at me. And of course, you have to replace the return nulls with the proper code. Let's go take a look over here at client. Some parts of the client are the same. You'll have to fill in the database API using retrofit, which is what you did before. You have to fill in the database sync proxy and the timer sync proxy and the timer API. These are all using retrofit like you did before. But here's the new piece for assignment 2C. This is the one that uses the HTTP interface mechanisms. And I think you'll agree once you get accustomed to them, they're much cleaner than using retrofit for a bunch of reasons. They're cleaner because you don't have that weird call class that comes back like you do with retrofit. They're also cleaner because the annotations you provide really mirror very nicely and map very nicely onto the same style of annotations you use to implement the controller annotations, things like @request_body, @request_param, and so on and so forth. And the other nice thing is that these all will basically return the reactive types, things like fluxes. And so you can basically figure out how to do these by taking a look at the examples we're going to cover once again in the quote services case study we'll be covering in class. So those are the things that you'll have to implement that are new. All the other stuff are things that you had done before for assignment 2B. So just be careful when you copy that over. Now, this is going to be the end of the assignment 2 family of examples. And so once you're done with this, we will then grade it and we'll move on to assignment 3 for the final part of the class. So now that we've walked through the specification and the skeletons, let's show how to run the tests. As before, we click on the Gradle tab, click on Recommender Server, Tasks, Verification, and then you double click on the Check menu item. And that will start building and running the tests. You can see the tests are beginning to run now. As I said, this takes a while, so we'll just let it run and then I'll go ahead and show all the results once it's finished. So as you can see, this took about 41 seconds to run on my computer, which is pretty fast, so it may take you a while to run everything. But if all goes well, then you should pass 107 tests with green check marks. Now, keep in mind, if something goes amiss and you're not getting the test to run in one fell swoop, you can always come along and run the tests individually just by clicking here and running the tests. So you could do that for each of the modules. And I might recommend doing that if you are having some compile problems or other things that may cause the tests not to run. But at any rate, please make sure that by the time you're all done, that you run all 107 tests and get them all to complete properly in order to be able to get full credit for the assignment. You can see here what happened when we just ran the tests that did the database EX portion. These are the new parts, and there are 22 tests there. So like I said, if you need to, you can always run them individually.